Hi everyone, so today we're gonna look at polynomial interpolation. We're still on this topic. So in this topic, I want to show you how to find the polynomial using three different methods. Okay, so we have Vandermonde approach. We have Lagrange approach, and the third one I have the Newton divided difference, so also known as NDD. Okay, so just recall before we start solving a set of problem here using these three approach, and I want to explain to you again what is polynomial. So polynomial is a function that can be written in this form: a0 plus a1x plus a2x squared plus a3x cubed plus a4x4 plus and so on to the degree of n. Okay, these are polynomial. Interpolation here means finding a function for a given set of data. I hope you get that. Okay, so by combining these two terms here, it means that we want to find the degree of the polynomial. In other words, we want to find the polynomial using interpolation approach. Okay, so interpolation is finding the function. So what are the function? The function will be in this form, the polynomial form. And there are a few other ways to find this. These are the three main approach that we're going to look at. Okay, so let's say you have a set of data given as 0, 0, 2, 1 over 4, 3 half, and 4, 3 over 4. Now the question is, find the polynomial. Find the polynomial. So we can quickly guess that the polynomial with 4 set of data, it should be degree 3. So your polynomial that you want to find is P3x. Okay, because 2 set of data will give you degree 1, linear. 3 set of data will give you degree 2, quadratic. And 4 set of data, not 3, 4 set of data will give you a cubic polynomial. Okay, so the first method that we want to use is Vandermonde. Let's focus on Vandermonde. Okay, this method approach here, let me just write down what are the P3. P3 equals to a0 plus a1x plus a2x squared plus a3x cubed. So these are my polynomial. Now I want to find a0, a1, a2, a3. So when I'm going to approach, first we got to construct a big matrix here. The first column will always be 1. The second column here will be your x value, such as 0, 2, 3, 4. 0, 2, 3, 4. Now the third column here will be the square of this. So 0, 2 squared is 4, 3 squared is 9, 4 squared is 16. Now the fourth column here will be the cubic of this. So 2 to the power of 3, 8, 3 to the power of 3, 27, and 4 to the power of 3. Give me 64. Okay, Vandermonde matrix must be a square matrix. Okay, it must be a square matrix. So this is my big X. Now what I want to find is all the coefficient A0, A1, A2, A3 equals to my Y. This is my A equals to Y, which are 0, 1 over 4, 1 over 2, and 3 over 4. Okay, so obviously you can find A by taking the inverse of X multiply with Y. Okay, so if you are okay with that, let's go on solving this. Okay, so let's move on. Let me just erase all this. Okay, so plus some calculator to get the inverse of A. So I just want to write here A equals to X inverse Y. So if I use my calculator to press the inverse of A and multiply with my Y here, my A here will be 0, negative 0.0208, 0.0938, negative 0.0104. Okay, so please find the inverse of this X inverse, this big X inverse, multiply with Y here. So if you have a MATLAB or any graphic calculator, you can just find the inverse easily. Okay, so by having this A, so we can write my P3X is A0, which is 0. Okay, minus 0.0208 X plus, this is my A1, now A2X squared, so 0.0938 X squared minus 0.0104 X cubed. So these are my polynomial using Vandermonde approach. Now next step is I want to show you how to find this polynomial using Lagrange. You should get the same polynomial equation. Okay, Lagrange polynomial or Lagrange approach. Okay, for this given set of data 2, 1, 4, 3 half, and 4, 3 over 4. Okay, so Lagrange approach here. If you recall my previous lecture, if you don't, please watch my video on Lagrange, written as L0 Y0 plus L1 Y1 plus L2 Y2 plus L3 Y3. Okay, what is this L? L are the values that we want to find, or equation that we want to find, not values. L is the equation using X. So this is my X0 Y0, X1 Y1, X2 Y2, X3 Y3. Okay, let's find all these L equations. So L0, where my I equals to 0, okay, given by the product sum of j from 1 to n. My n is 3 in this case, and j cannot be equal than I, which is 0. X minus xj over xi minus xj. Okay, so I have for j is 1, so I have x minus x1 multiply with x minus x2 up to 3. So x minus x3. Because j cannot be 0, so you cannot start with 0 and then divide by. The reason is if you have 0 here, so if you look at here, my I is 0, right? So if my I is x naught minus, if my j is 0, you'll have x naught minus x naught. So you cannot divide by the denominator. So you'll have x minus, start j is 1, x naught minus x2, x naught minus x3. So you just have to put on all these x1, x2, x3 from this to this function. So we have x minus 2, x minus 3, x minus 4 over, okay, x naught is 0, 0 minus 2, so we have minus 2, 0 minus 3, we have minus 3, and 0 minus 4, we have minus 4. So I have x minus 2, x minus 3, and x minus 4 over negative 24. Okay, so this is just L naught, and then L1 is given by the product from j equals to 0. In this case, we can use 0 now, since my I is 1, but j cannot be 1, 3 up to 3, x minus xj over xi minus xj. Okay, so this will give me x minus x naught, j start from 0, x minus x, 2. Why not 1? Because I is 1 and j cannot be 1. So start from 2 and x minus x3 over x naught is 1. So xi, so x I is start from 1, x1 minus x naught, x1 minus x2, x1 minus x3. Okay, putting all this value, very easy, just put all the x naught, x1, x2 value will give me x minus 3, x minus 4 over 4. Okay, now continuing, finding my L2, okay, where the product from j equals to 0 to 3, but since I equals to 2, my j cannot be equals to 2. X minus xj over xi minus xj. So I have x minus x naught, x minus x1, x minus x3 divided by x2 minus x naught, x2 minus x1, and x2 minus x3. So simplifying this will give me x minus 2 over x minus 4 over negative 3. Okay, this is crazy. You still need to find L3. It's taking longer time than using Vandermonde approach. Now for this case, since I is 3, so we have to find the summation up to 2. My j start from 0, but j cannot be equals then 3. So x minus xj over xi minus xj. Okay, I'm just gonna do it very quickly because I don't have much time. So by solving this, you'll get the idea actually. So you have x minus 2, x minus 3 over 8. Okay, now since you have found all these values of, so you can substitute. So this one will be L naught y naught plus L1 y1 plus L2 y2 plus L3 y3. Okay, it's actually, when you put in all this value that you've obtained, you will end up having the same answer, negative 0.0104 x3 plus 0.0938 x squared minus 0.0208x. Similar with the Vandermonde solution. Okay, so the next method I want to show you is NDD. Okay, the next method that we want to show is by using Newton divided difference, NDD. Okay, I've shown you this for the simple set of data where you have 0, 0, 2, a quarter, 3 half, and 4, 3 over 4. So Vandermonde and Lagrange polynomial give you the same polynomial function. We can also see that using Newton divided difference, NDD approach also give the same polynomial. Okay, so we have, first write down the first column of x values. These are the values of x, where we have 0, 2, 3, 4. And then we have the y values such as 0, 1 over 4, 1 over 2, and 3 over 4. Okay, so Newton divided difference, we define the diagonal values, all the diagonal entries. So we need to find A, B, C, D, E, F, all this. Okay, to find A, to find entry in A, so 104 minus 0 divide by 2 minus 0. That will give you 1 over 8. And then to find B, so we have 1 over 2 minus 1 over 4 divided by 3 minus 2. That will give you 1 over 4. And then to find C, I have 3 over 4 minus half divided by 4 minus 3, okay? That will give me 1 over 4. So now I can put all this value here. Just erase this A, B, C and put the value 1 over 8, 1 over 4, and 1 over 4. Okay, so continuing to find D, now I have 1 over 4 minus 1 over 8 divide by, now I'll have to skip one entry here, so it'll be 3 minus 0. Okay, that will give me 1 over 24. Now, to find E here, 1 over 4 minus 1 over 4, so it's already 0, so E will be 0 value. So, replacing this with the values that we have obtained, so this is 1 over 24 and this is 0. Okay, lastly to find F. So F here, the entries in F can be found by 0 minus 1 over 24 divide by, okay, this minus this, divide by, now we got to skip 2 terms here. So every column on the diagonal, you got to skip 1 term at a time, okay? So this will be 4 minus 0. 4 minus 0. That will give you negative 1 over 96. Okay, so now I found all the values. So this is negative 1 over 96. Okay, so from here now, I can write P3. Okay, where's my P3? So let me just write this, this one. These are the x values, right? So this can be obtained by letting x minus 0. Okay, this is x minus 2. This is x minus 3 and x minus 4. Okay, because x minus 2 equals to 0, so x will give you 2. Okay, so what is P3? P3 as is written by considering all this diagonal value multiply with the x here. So 0 plus 1 over 8. Now I have x minus 0 plus 1 over 24, x minus 0, x minus 2. I have x minus 0 is x minus 2 plus negative 1 over 96. Now I have to consider x minus 0, x minus 2, and x minus 3. So x minus 0 is x minus 2, and x minus 3. So these are the polynomial function you have obtained using NDD. And surprisingly, if I expand this, just multiply and expand this, you will obtain the similar equation that you have obtained by using Lagrange and Vandermonde. So you'll have 0.0208x plus 0.0938x squared minus 0.0104x cubed. Okay, so we have seen 3 different approaches: Lagrange, Vandermonde, and NDD. So both have given you one similar polynomial P3x, which are negative 0.0104x3 plus 0.0938x2 minus 0.0208x. Okay, so which one is the best method? So it's hard to say which one, okay? Vandermonde matrix, you need to solve a big system. Okay, depends on the polynomial. So Vandermonde matrix have a big matrix here that you need to solve. That would be a bit costly. And Lagrange polynomial or Lagrange approach, there are a lot of calculation. It can get tedious, but it's simple arithmetic, so it's not very costly. For NDD here, okay, it's very easy, quick, very easy. Okay, so you involve a little bit of extra calculation here when you're doing a division. Okay, so it depends what data set you have. Now, if the question here asks you to evaluate P3 for x equals to 2. Okay, so how do you find it? So you can the normal way that you can do is substitute my x value here, 2 to the power of 3 plus 0.0938 2 to the power squared minus 0.0208 times 2. Okay, and pressing the calculator should give you 0.2504. Okay, but if you have also learned another method called another way to evaluate this is by using Horner scheme. Okay, Horner scheme is very convenient to evaluate the polynomial for the given x value. So I can show this quickly here. So I have arranged this into the highest coefficient. Okay, so this is my A3, A2, A1, and A0 is 0. So I have negative 0.0104, 0.0938, negative 0.0208, and 0. Okay, Now, if you don't know this, you have to refer to my video on Horner scheme. So you want to find for x equals to 2. So this write a 2 here. Now the first value here will be immediately comes from my A3. So this will be negative 0.0104. Okay, so this is multiplied. Negative 0.0104 times 2. I'm going to write it here. 0.0208 and add this two value. 0.0938 plus negative 0.0208. Add these two will give me 0.073. 0.073 times 2 will give you 0.146. Now adding these two again, negative 0.0208 plus 0.146 will give me 0.1252. Now 0.1252 times 2, write it here, 0.2504. Now add this 2 will give me 0.2504. Now these are the value for P3 when you substitute x equals to 2. Okay, so this is a Horner scheme. And you can also use long division. Okay, so there are many ways to find or evaluate the values. Okay, so this covers the whole topic of polynomial interpolation, where I've shown you there are 3 methods: Vandermonde, okay, and then Lagrange, and also lastly the NDD table. Okay, you can use either one to find the polynomial P and X. Okay, this is a polynomial, n is the degree of the polynomial, and to find this function is called interpolation for a given set of data. Okay, so that's all. See you next time. Bye.